Chapter 1.4 is angle measure. We have quite a long list of vocabulary words. The first one is a ray. A ray is part of a line. It has one endpoint and extends indefinitely in one direction. So it's like a line, but it has an endpoint. So it looks like this. A, B is an example. Right. So this would be ray AB, and we would write it like this. Right, AB with a line above it and an arrow on one end. The next one is an opposite ray. Opposite rays. Opposite rays. And how does this look? This is a line where we have 2 points. And we have A, B, C. So we have a line with 2 points AC, and we have a point on the line, and it determines two opposite rays. And what are the opposite rays here? It's AB, or I'm sorry, BA, right? Starting with B, going to A, and we have BC going off to the right direction. So I could say AB, or ray AB, and ray BC are opposite rays, like that. Next is an angle formed by two non-collinear rays that have a common endpoint. So let me go ahead and draw this. So the rays, an angle formed by two non-collinear rays. So the rays are non-collinear, meaning they're not on the same line, but they have a common endpoint. So it looks like this. So we have A, B, C. They have a common endpoint here, and so ray AB and ray AC is an angle. They form an angle, right? And so I could say angle ABC. The angle can also be delineated with a number in the angle, so I could also say angle 1, like that. And here we have rays that form an angle, and these are sides. Okay. So in the same picture, where we have A as the common endpoint, we have ray B, AB, we have ray AC, right? The rays that form an angle are sides. So I could say ray AB and ray AC are sides. Common endpoint of the two rays in an angle is called a vertex. Vertex. So again, if I have my rays here, then my vertex would be the common endpoint. So that's A. So I'm going to say vertex A. Like that. Points that lie inside of an angle are called interior points. So this is interior points. Okay. There's no notation for that, but what that means is if I have an angle like so, right, the interior points would be the points inside of the ray. Okay. The next one is exterior points. So we have exterior points, and it's similar, right? If we have an angle that looks like that, then the exterior points is everything outside of the angle. It's all the exterior points. And here we have the unit of measure for an angle are called degrees. So we have degrees, right? So here if I have an angle that looks like this, and I could say this is 45 degrees. 45 degrees, right? And the notation for degrees is a small little circle. So if D is my degrees, I could say D degrees, or some number degrees. Down at the bottom, we have an angle whose measurement is exactly 90 degrees, and that's a right angle. Right angle. The notation for a right angle, it looks like that. An angle with a two perpendicular lines with a small little box there in the corner. So what is a right angle? It's 90 degrees. 90 degrees. An angle whose measurement is less than 90 degrees but greater than 0, right? So here's 0 degrees, okay, and here's 90 degrees. So if you have an angle that's smaller than 90 degrees, let's say here or here or here, we call them acute angles. Acute angles. And the notation for acute angle, well, there's no real notation here, but I can give you an example. Here is an acute angle, right? This angle is less than 90 degrees, and maybe I could put a 45 degrees. This is less than 90. Right? And then here we have a angle whose measurement is less than 180, and 180 would make a line, right? A line. This is 180 degrees. So from here to here is 180 degrees. So less than that, but greater than 90 degrees. So bigger than a right angle. These are called obtuse angles. Obtuse angles. And so obtuse angle, an example would be something that looks like that, right? And so I could say this is 150 degrees, maybe. Right? So in between 90 and 180. And then here's a ray that divides an angle into two congruent angles. This is an angle bisector. Angle bisector. And so over here, I could say, here's my angle, and I have my angle bisector. And it divides the angle to two congruent angles. And we could say they're congruent by having these two arcs, right? So that means that this angle is the same as that angle. Okay, so those are our vocabulary words.